Okay, in today's class, let's look into decay of timber. What do you mean by decay? Huh? What do you mean by decay? Richard? It's afternoon class. You got to answer. Will interact or else you'll sleep. Carolyn? Decay. Getting spoiled. Disintegration. Okay, note on the definition for decay. The disintegration of timber substance. The disintegration of timber substance due to the action of timber destroying agents is known as decay. Timber destroying agents. So what are the timber destroying agents? Fungi, marine borers, and what else? Insects, termites. Yes, not on termites. So what will happen if these destroying agents get into the timber? It will start destroying what? The timber. How does that happen? Okay, how do fungi will grow inside the timber? Moisture. What about marine borers? Have you seen timbers being used in marine structures? You know what? You know about marine structures? No? Do you know what is marine? Sea. Marine structures are in the port. Have you seen port? Yes. Where the ships comes and lands. Have you seen that? Have you learned about port? At least in your school. Have you seen the port in picture, or at least have you seen the timbers have been used there? Yes. See, if you go to Ooty boathouse also, there you can see the timber columns being placed there. Have you seen Ooty people? So when the timbers are immersed in sea water, when it is used for timber structures, okay, there is a destroying agent called marine borers. It destroys the timber. So how does it destroy the timber? A fungi, when it gets in, okay, sorry, what about termites? Guys, answer. Sleeping. Huh? Eats away the wood. Eats away the wood. Have you seen timber getting deteriorated? What do you mean by deteriorated? Breaking. Have you seen timber breaking into small pieces? Have you seen that? How does that happen? Because of these timber destroying agents, it gets into the timber, it eats the timber, as I said. Okay, so after a period of time, see, if the marine borers, what are they doing is, it's in the sea water. Yes, and already because of the sea water, the timber is getting affected, and due to the marine borers, it eats, and then the timber is disintegrated into many things. See, the way to maintain the timber is, if you keep it, if you keep the timber in a dry place, throughout. If you maintain it dry, it lasts for long, or if you keep it wet, then it lasts long. But as I said in yesterday's class, if you keep on changing, like few hours dry and few hours wet and few hours dry and few hours wet, it will destroy the timber. Continue writing. The various timber destroying agents are fungi, marine borers, and insects. Among among what? Fungi and marine borers and insects, fungi is most destructive. Fungi is most destructive. And more about fungi. Fungi develops in damp places. Do you know damp places? Wet places? Where you won't find any water, but that you will find some cold, you won't be comfortable being there. Usually in the underground. So fungi is more destructive. So fungi develops in damp places. You want me to dictate, or you will write it later, or you will get the notes, or you want me to dictate the whole decay of timber? Okay, let me finish explaining everything. What do you mean by rot? ROT. Rot. Chandani. Rot. Decomposition due to what? Due to these destroying agents, it gets into dry rot and wet rot. Yesterday I showed you some pictures, no? Did you see rot in that, dry rot and wet rot? Do you remember that? I told you about it. I told you yesterday, see, look into rot, the rot which I will explain later. Did you see the rot? No? Did I copy it here in the desktop? Okay. So dry rot, how dry rot is forming is, it forms in the places of unventilated places. In unventilated places and in the underground, in damp places, these dry rots are getting formed. The wet rot is in the place of where? Yes, wet rot. Where is it? Wet rot is forming? Do you have any idea of wet rot? And another thing about dry rot is it kills the living trees. Determine the wait. The safe working stress. The safe working stress. The safe working stress. The safe working stress in compression of a standard timber. The safe working stress in compression of a standard timber, in bracket write Daman, DHA MAN, Daman, close the bracket, for inside location. It's a type of wood. Standard timber, Daman, for inside location, comma, parallel to the grain is 12 Newton per mm square. parallel to the grain is 12 Newton per mm square, and that perpendicular to the grain is 6 Newton per mm square, and that perpendicular to the grain is 6 Newton per mm square. Determine the safe working stress. Determine the safe working stress for this timber. Determine the safe working stress for this timber if the timber is of selected grade. If the timber is of selected grade, and if the timber is of the common grade, and if the timber is of common grade, and the timber is of common grade, in bracket that is grade 2. Read the question. What is given in the question? The safe working stress in compression of a standard timber for inside location for two things. One is parallel, another thing is perpendicular. You know which is grains, right? The grains, yesterday I showed you the lines. Okay. So parallel to the grain is how much? 12 Newton per mm square. Perpendicular to the grain is 6 Newton per mm square. What are they asking us to find? Safe working stress for the same timber, selected grade, and if the timber is of common grade. What is selected grade? Jijo, what is selected grade? Harimat? Huh? For standard grade, it has certain specified limits. What about the other? Common grade. Harish. Common grade. Go through the previous notes. Inferior to standard grade. They have given for what? For standard grade, right? And the same way, the safe working stress note on the next one. What is the next one given in the question? Safe working stress in compression perpendicular to the grain, right? I'll go to the next page, boys. See, this is given in the question. I'll go to the next page. It's there in the question. Copy it. What did I do? safe working stress in what? In compression perpendicular to the grain is 6 Newton per mm square. And to find, what do we need to find? Write down to find, to determine what? Safe axial compressive. What is given in the question? To determine what? Write that in and to find. To find safe working stress in compression parallel to the grain as well as perpendicular to the grain, right? See, there are 3 grades, we know that, right? What are the grades? Selected grade, standard and common. Listen carefully. The safe working stress is given for what? Standard grade now. Yes or no? And we need to find out for selected grade and common grade. Okay, there is a formula to find out the safe working stress for selected grade as well as to the common grade. You finish writing to find? We'll go to the next page. Formula or you can say it also conditions. For what? Standard grade is given, right? We need to find out for selected grade and common grade. For selected grade, safe axial compressive stress. First is what? Parallel or perpendicular? Parallel to the grain. It is 1.6 times the standard grade. For standard grade, the compressive stress to the compressive stress parallel to grain is how much? I'll explain clearly again. Listen. To find out the safe axial compressive stress parallel to the grain for selected grade, the formula is it is 1.16 times the standard grade. Okay, for the standard grade, the compressive safe axial compressive stress parallel to the grain value. How much is that? So 1.6 into 116 into 12. That is the answer for selected grade. I'll explain again. It is 1.6 into safe axial compressive stress parallel to the grain. This is standard grade. (1.16) into what is this value? 12. So 1.16 into 12 is how much? How much? The similar way for the perpendicular. See, I am writing short, you got to write the whole sentence. Safe axial compressive stress perpendicular to the grain, that is also 1.16 into what? That is safe axial compressive stress parallel to perpendicular to the grain of what? Standard grade. What is the answer? This one. Boys, for this one. 13.92 Newton per mm square. For the perpendicular, tell me the answer, Jijo. Where's the calculator? 6.9. I'll go to the next page. Finished copying. You understood? That is the formula condition. Where? See, it is 1.16 into safe axial compressive stress here it comes perpendicular to the grain of standard grades. That value is given as how much? 6. So 1.16 into 6. See, the same procedure for common grade. For common grade, instead of 1.16, it is 0.84 times of the standard grade. So 0.84 into standard grade value. Start solving. 0.84 into standard grade for that is for the common grade. 0.84 into so this 1.16 and 0.84, okay, this you will find out in the notes of grading. I'll give you notes for grading. You know how selected grade, grade 1, grade 2 and all is done, right? That itself they have given. This is the constant value for to find out the safe axial compressive stress for selected grade and common grade. What do you mean by standard grade? Yes. For perpendicular it is also, it's 0.84. Boys, solve and show me. Fast. Only if you solve and show me, then I'll put attendance. Done. Tell me the answer. For what? What is the answer for selected grade? One is 13.92 Newton per mm square. Another one 6.96 Newton per mm square. For common grade, 10.08 Newton per mm square. What is the other one? It's 5.04 Newton per mm square.